This comes out of section 5.4, the second derivative test. What we have here is a relatively simple test for whether something is a max or a min. Now we already have tests for that when we've been doing the first derivative and saying, okay, if it increases and then starts decreasing, it looks like we have a maximum. If it decreases and increases, it looks like we have a minimum. This is an even easier test in some situations. It says that as long as you have a second derivative that exists and is continuous throughout the domain of the function, so that means you've got a polynomial or a relatively simple function that doesn't have asymptotes and nasty things going on, then if the first derivative is 0 and the second derivative is positive, that means that you have, first of all, a critical value where the first derivative is 0 means that you have a tangent line of 0, but you also have concave up. And so those two things combined tells me that we have a local min. So a local min at this critical number C. Now if we start with the same, that the first derivative is 0, but the second derivative is negative, we have a spot that looks like this, where we have tangent line with a slope of 0 but concave down, and so we have a local max. So to do an example of this, with a nice simple cubic function here, find the local maximum of f of x equals x cubed minus 48x plus 3. So find the derivative is 3x squared minus 48. Can factor that fairly nicely to find x squared minus 16. So 3x minus 4, x plus 4. So I know that there are two critical numbers at x equals 4 and negative 4. Now, without doing a whole number line of increasing and decreasing, if I find the second derivative, I can just say, oh, that's 6x. So 6x, if I put in x equals 4, is positive, which means I'm concave up. So x equals 4 is a local min, because we're looking at this type of a picture, concave up, and x equals negative 4 is a local max, because we've got concave down and first derivative equal to 0. If we wanted the actual values, we just put in 4 and negative 4 into the original function and figure out what lovely numbers those are going to give us.